Good morning, sir.
Good morning, sir. Good morning. Jacobian of implicit function. The variable x, y, u, v, these are Jacobian of implicit function. An explicit function. Explicit function means dependent variable and independent variable we can get separately. Means independent variable right separable from dependent variable. So that is the explicit function. If you could not write, so that is the implicit function. So suppose our function is f1, let f1 xy uv equal to 0, and another is f2 xy uv equal to 0. So now here uv are the implicit functions of xy, where u and v are implicit functions of x and y. Now in this case, Jacobian of uv with respect to xy is, so there is a formula -1 के power 2 Jacobian of f1 f2 with respect to xy and divided by Jacobian of f1 f2 with respect to uv. Jacobian of uv. Suppose I want to extend this to, suppose in this case u and v are implicit functions of x and y.
सर यहाँ -1 नहीं लिख सकते?
नहीं, वही मैं बता रहा हूँ. -1 का स्क्वायर अगर ये 3 होगा, if u, v, w are implicit functions of x, y and z, so now this case -1 के power 3. जैसे सपोज एक इसका जनरल फॉर्म लिख लेते हैं. सपोज u1 u2 डॉट un, n number of variables u1 u2 un are implicit functions of x1 x2 xn. So now in this case, ठीक है, u1 u2 un are implicit functions of x1 x2 xn, and their function is, suppose f1 x1 x2 xn u1 u2 u1 equal to 0. Similarly, there are n functions, means f1, x1, x2, dot dot dot, xn u1 u2 dot dot dot, un equal to 0. Similarly, f2 equal to 0 dot dot dot, fn equal to 0. Now in this case, u1 u2 un are implicit functions of x1 x2 xn. So therefore Jacobian of u1 u2 un with respect to x1 x2 xn. So this is minus 1 की power n, and Jacobian of f1 f2 fn over, with respect to, this is x1 x2 xn, x1 x2 xn, and Jacobian of same f1 f2 fn with respect to u1 u2 un. So this is the journey. Suppose if Jacobian of means UVW, suppose UVW are implicit functions of x, y and z, and f1, f2, f3, f1 equal to 0, f2 equal to 0 and f3 equal to 0. f1, f2 all are the functions of all are functions of x, y, z, u, v and w. Okay. So now in this case, Jacobian of u, v, w with respect to x, y, z is what? Hello? What is the Jacobian of u, v, w with respect to x, y, z?
किसी भी दो फंक्शन का यूज कर
माइनस वन क्यूब माइनस वन की पावर 3
minus 1 के पावर 3. Next,
जैकोबियन ऑफ f1 f2
f1 f2 f3
with respect to
x y z
x y z.
correct. With respect to u, v,
u will
w. So you can write the Jacobian of implicit function. So this is the example. If x square plus y square plus u square minus v square equal to 0 and uv plus xy equal to 0, then Jacobian of uv with respect to xy equal to x square minus y square by u square plus v square. Okay. So first you write f1. F1 is, there are two choices, either this is f1 or this is f1. So you can write any one is the f1. First one is the f1 x square plus y square plus u square minus v square, and f2 is uv plus xy. For this one, Jacobian of uv with respect to xy. So now write the formula. Jacobian of uv with respect to xy is y square. Jacobian of f1 f2 with respect to xy, f2 with respect to uv. This is the formula number 1. So now you can find separately numerator and denominator. f1 f, this is determinant. Differentiate f1 with respect to x, differentiate f1 with respect to y, f1 with respect to x and f1 with respect to y. Differentiate f2 with respect to x and f2 with respect to y. And f1 is x square plus y square plus u square minus v square. Differentiate with respect to x. So this is the partial differentiation. So other variables are treated as constant. When you differentiate f1 with respect to x, this is 2x. When you differentiate with respect to y, this is the 2y. So 2x and 2y. Differentiate f2 with respect to x. This is constant 0. When you differentiate with respect to x, so this is 1 y. And when you differentiate with respect to y, this is x. So y x. After simplification, 2x square minus 2y square. This is equation number 2. Jacobian of f1 f2 with respect to uv. So differentiate f1 with respect to u and v. Differentiate f2 with respect to u and v. So differentiation of f1 with respect to u and v. So this is 2u and with respect to v minus 2v. 2u minus. Now differentiate f2 with respect to u. So this is 1, this is 0. So v. When you differentiate f2 with respect to v, so this is u. So v and u. So 2u square plus 2v square. So now by formula number 1, So suppose this is denoted by J. Let so J equal to, and suppose this is J. So J equal to minus 1 का square 2 x square minus 2y square and divided by 2 u square plus 2 v square. This is हो गया ठीक है. So 2 cancel, minus 1 का square plus 1, so x square minus y square divided by u square plus v square. So this is the homework exercise. You give u cube plus v cube plus w cube equal to x plus y and u square plus v square w square equal to x cube plus y cube plus z cube, and u plus v plus w equal to x square plus y square plus z square. ठीक है. If u cube plus v cube, so you have the two choices. If you write f1, so u cube plus v cube plus w cube minus x minus y minus z is 0. Or you can write f1 is x plus y plus z minus u cube minus v cube minus w 0. Similarly, you can
तो
write.
ये रिफ्रेश आ जा रहा है स्क्रीन पे.
वो पहले से मुझे स्टार्ट करना पड़ेगा, रीस्टार्ट.
अच्छा ठीक है, चल देखिए.
ठीक है, अब मैं वो हटा दूंगा आपसे. सो ये देखो, सो यू कैन राइट फ्रॉम फर्स्ट वन f1, f2 and f3. So prove that Jacobian of u v w with respect to x y z equal to y minus z, z minus x, x minus y, and divided by u minus v, v minus w, and w minus u. Okay, you can. Acha, can we find this exercise, this problem? How can we write Jacobian of x, y, z with respect to u, v, w? How can we write this one? Actually, u, v, w are the implicit functions of x, y, z. Similarly, we can write x, y, z are implicit functions of u, v, w. Then hello.
Yes, sir. Yes, sir.
तो कैसे लिखेंगे?
-1 के पावर क्यू
उनके पावर क्यू
जैकोबियन ऑफ f1 f2 f3
एक मिनट.
डिवाइडेड बाय जैकोबियन ऑफ x y z
करेक्ट. एक्स वाई जेड फिर जैकोबियन ऑफ
f1 f2
f3 बाई
u v w.
u v w. If you find this one, correct. बस हो गया. एक और इसका यूज अब जाता है पार्शियल डेरिवेटिव्स ऑफ implicit by Jacobian. Again, in this case, suppose